Pluto made them come all along. Pluto's circle crosses that of another planet. Pluto, the puzzling little planet at the external scopes of our nearby planet group, is working up energy on the planet of cosmology. Ongoing reports indicate a conceivable experience with Neptune, raising worries among researchers and space fans. Striking figures like Neil deGrasse Tyson and Michio Kaku have sounded cautions about the ramifications of this infinite occasion. But how did Pluto end up on a crash course with its adjoining planet? And what could this heavenly conflict mean for life on Earth? Join us as we disentangle how something huge just slammed into Neptune and how researchers have been left stressed by this vast irregularity. Pluto, once hailed as an undeniable planet, went through a change in its status, being renamed as a bantam planet due to its unconventional circle. Notwithstanding this downgrade, Pluto actually spellbinds and interests the cosmic local area. Later forecasts from regarded researchers like Neil deGrasse Tyson and Michio Kaku have raised worries about Pluto's direction possibly converging with Neptune, indicating an approaching string of impact between the two divine bodies which could have critical repercussions for Earth. Pluto's excursion around the Sun stands apart because of its exceptional attributes within our nearby planet group. Its circle is particularly extensive, crossing a stunning number of astronomical units. Since its revelation in 1930, Pluto has yet to finish a full unrest around the Sun. Adding to its persona is the profoundly stretched state of its circle. A departure from the more roundabout ways followed by the significant planets, Pluto's circle strays by 17 degrees from the ecliptic plane, giving its way a more extreme grade contrasted with different planets. The blend of Pluto's nature and its curved circle presents layers of intricacy to its orbital example. One prominent angle is its occasional converion with Neptune's circle. For about 20 years during each circle, Pluto ventures nearer to the Sun than Neptune, resisting assumptions in view of their separate situations in the nearby planet group. Digging further into Pluto's circle, it's captivating to take note that it's anything but an amazing circle but rather a lengthened circle resembling more of an oval shape. This remarkable circle results in critical varieties in Pluto's separation from the Sun all through its excursion. At its nearest approach, Pluto goes inside around 30 astronomical units of the Sun, while at its farthest point it comes to more than 49 away, 2 times the distance of Neptune from the Sun. In addition, Pluto's circle is leaned at a point relative to the circles of the significant planets in our nearby planet group. This tendency not just adds to the intricacy of its circle, but also assumes a vital part in its collaborations with other heavenly bodies, especially Neptune. When Pluto encounters Neptune, their gravitational influences each other, adjusting their directions over time. The many-sided dance between Pluto and Neptune highlights the dynamic nature of our nearby planet group. While Pluto was once viewed as a solitary drifter in the outer reaches, its nearby encounters with Neptune highlight the interconnectedness of heavenly bodies, each applying gravitational forces that shape the paths of others. In later years, advancements in observational technology have permitted cosmologists to track Pluto's movements with extraordinary accuracy. This has prompted a more profound comprehension of its circle and its likely ramifications for the stability of the outer nearby planet group. While the probability of a direct impact between Pluto and Neptune remains low, the possibility can't be completely discounted, prompting continued monitoring and study by the astronomical community. Regardless of its modest size and far-off location, Pluto proceeds to command attention and interest among researchers and fans alike. The question emerges: why hasn't there been an accident between Pluto and Neptune? The response lies in the pull of gravity from different planets. Stargazers began concentrating on Pluto's way not long after tracking down it, and its course baffled them. Dissimilar to most planets that stick near similar plane as they circle the Sun, called the ecliptic plane, Pluto stands apart with its precarious point and oval-shaped circle. The mystery expanded when they understood Pluto's way crosses Neptune. Regardless of these intricacies, Pluto's circle remains stable, exhibiting the complex mechanics of space. Learning how 3 divine bodies move and collaborate gravitationally, like Pluto, Neptune, and the Sun, is a big challenge. It's like attempting to foresee where they'll go based on where they start and how they pull on each other. For Pluto, this challenge reveals how its way, Neptune's way, and the sun's arrange all work terms like a simulate scope libration and the VSOP wavering assist researchers with settling this enormous riddle. A simulation is crucial for keeping planets in their circles. When Pluto crosses Neptune's way, it's at least 90 degrees away, keeping them from crashing. Scope libration ensures that when Pluto approaches Neptune or other huge planets, it's well over their way, reducing the chance of a crash. The VSOP wavering, named after researchers von Zappel, Steves, and Saplin, figures out why Pluto's circle appears to be abnormal yet remains consistent over the long run. Despite the confusion in space, some patterns and rules keep things in request. These guidelines keep Pluto's circle stable, stalling crashes with Neptune or changes in its way. The possibility of orbital mayhem, showing how a heavenly body's way is extremely delicate to where it begins, is very much represented by Pluto. Indeed, even little changes in its situation or speed can wreck its circle over a long time. Researchers use PC simulations to sort out how Pluto moves in space. These simulations use extravagant math to duplicate how Pluto associates with other space stuff like Neptune. By tweaking these reproductions just a tad, cosmologists can perceive how small changes can change Pluto's way. In the last part of the 1900s, these reenactments tracked down something fascinating about Pluto's circle. Even though there are things that ought to make it stable, Pluto's circle can still be eccentric. Simply a minuscule difference in where Pluto begins or how quick it's going can roll out enormous improvements over numerous years. However, even with this disorder, Pluto's circle remains stable for a super long time, like billions of years. This suggests that despite the fact that Pluto looks out of control, its excursion around the Sun follows a lot of some kind or another. Anticipating what will occur with planets like Pluto, which have awkward circles, is hard. These frameworks are so capricious that it's hard to think about what will occur over the long haul. Recreations help us find out about what could occur, yet they likewise show us that we can't foresee all that completely. These models need definite beginning stages, and they reproduce muddled stuff. Even a little mix-up can prompt entirely unexpected outcomes, which makes it hard to make precise forecasts. Figuring out Pluto's circle is significant, particularly when we think about whether it could collide with Neptune later on. This information assists us with seeing better how our solar framework works. Pluto's circle shows us how circles that appear to be flimsy can adjust due to gravity and how things move in space. Continuing to watch is significant, also concentrating on these things so we can comprehend where we fit in the universe. At the point when we investigate space, we figure out that things can be eccentric, and Pluto's circle is an incredible illustration of that flightiness. Pluto's circle isn't like those of different planets. It's more oval-shaped, which implies it's not a perfect circle. Here and there, it even gets nearer to the Sun than Neptune does. This can make things interesting because Neptune is also out there, cruising along its way. There's a little opportunity that Pluto and Neptune could find one another sooner or later. Notwithstanding its odd circle, Pluto figures out how to stay away from Neptune most of the time. This is on the grounds of something referred to as gravitational forces. Gravity resembles an undetectable power that pulls things toward one another. So even though Pluto and Neptune could appear as though they're on a brief crash course, their circles are painstakingly arranged moves, directed by the draw of gravity. Pluto's circle instructs us that space is loaded with shocks. What appears to be tumultuous from the start look can be a delicate equilibrium of powers. By concentrating on Pluto's circle, researchers gain insights into the mind-boggling mechanics of our planetary group. This ongoing observation and investigation are fundamental for extending our information on the universe and our place inside it. Imagine if Pluto and Neptune impacted. It would be an inestimable occasion, sending shockwaves through our comprehension of the nearby planet group. While we've gained ground in understanding space, what is going on shows that we actually have a long way to go. Concentrating on what huge planets mean for Pluto's way gives us significant pieces of information about how our whole nearby planet group works. It shows us that where every planet is and how it moves can change the ways of other things in space. Despite the fact that space is convoluted, some top researchers are stressed that Pluto could collide with Neptune. This makes them can't help thinking about why this could happen, despite the fact that it appears unlikely. Neil deGrasse Tyson, a renowned space researcher, has some interesting thoughts regarding Pluto. He imagines that renaming Pluto as a bantam planet, not a big one like Earth, is a step forward. He accepts we're generally learning new things about how things move in space. Tyson sees Pluto's abnormal way as a sign that there's still a ton we don't realize. He feels that the mysteries of space are so intriguing. He likewise knows that enormous occasions in space, like Pluto's renaming, get individuals intrigued in space science. Tyson needs to help individuals grasp the cool and at times unusual things about how space functions. He thinks it's critical to discuss how space mechanics can shock us. Tyson works with different researchers to caution individuals about the potential risks of Pluto's peculiar way. In the wake of concentrating on Pluto a ton, the fact that it could collide with Neptune one day makes him focused. He says this could cause huge issues for our whole planetary group. An accident among Pluto and Neptune would be an uncommon and serious occasion. It would discharge a ton of energy and could break separated Pluto. Pieces from the accident could fly around space and hit different planets and moons. Neptune could likewise feel the effect and change how it moves. Renowned theoretical physicist Michio Kaku, known for his contributions to string theory and science communication, offers an interesting perspective on space exploration. He thinks that understanding the future of space travel and the relationship between celestial mechanics and theoretical physics can be gathered from concentrating on peculiarities like Pluto's circle. Kaku considers Pluto's circle to be a window into the future of space exploration. By grasping the multifaceted gravitational interactions and orbital dynamics of heavenly bodies like Pluto, we can improve future space missions, helping with safer navigation through the solar system, predicting potential risks, and planning missions to far-off corners of our cosmic neighborhood. Kaku emphasizes that patterns gained from Pluto's circle can be applied to exploring other heavenly bodies, providing a roadmap for deciphering remote universes. He frequently highlights the deep connection between celestial mechanics and theoretical physics, stressing that the movements and interactions of planets, for example, the gravitational dance between Pluto and Neptune, are rooted in fundamental principles of physics. Kaku's work in theoretical physics, especially string theory, aims to unravel these principles at their core. He suggests that concentrated on the complexities of celestial mechanics like Pluto's circle can offer insights into the underlying laws of the universe. Similar to Tyson, Kaku has also pondered the potential collision of celestial bodies, relating it to his theories about the universe. A collision between Pluto and Neptune, while significant in astronomy, could offer a unique observational opportunity, potentially contributing to how we might interpret string theory. String theory, which replaces point-like particles with one-dimensional strings, attempts to describe the fundamental forces and matter in the universe. Such an impact could create extreme conditions of energy and gravity, shedding light on the behavior of fundamental particles and forces under extreme conditions, a key focus in string theory. Additionally, the gravitational waves produced by such an impact could provide valuable data for testing predictions of string theory concerning gravity and spacetime. While the direct impact on Earth would be insignificant due to our distance from the outer planet AR group, the scientific implications could be profound. Understanding events like this could expand our understanding of the fundamental nature of the universe as described by string theory and other theoretical physics areas. Pluto's unique qualities, influenced by the gravitational forces of neighboring planets, especially Neptune, highlight the complex and dynamic nature of space. Yet, the universe holds many mysteries, and the three-body issue is just one of them. Researchers anticipate other potential disasters, highlighting the ongoing quest for understanding and exploration in the vast universe. Although it's exceptionally unlikely, there's still a small possibility of planets capturing each other in space. This can occur because planets' paths are influenced by various factors like gravity from other planets, which researchers call the three-body issue. In places like the TRAPPIST-1 system, where there are 7 Earth-sized planets, the gravitational forces create a kind of rhythm in how the planets move called orbital resonances. Over time, these paths can make a planet's path less stable and could lead to collisions. Though systems like TRAPPIST-1 are teeming with planets, crashes aren't happening right now. Researchers keep an eye on these systems to understand how planets influence each other's paths, especially when they get close. This helps us understand how planets move in space. Sometimes, There are rogue planets that don't orbit a star and float around unusually. These planets used to be part of a star system but got ejected due to things like gravity or when another star came too close. Over time, these wandering planets can travel far and could run into other star systems. But since space is mostly empty, the chance of them hitting another planet is very low. Rogue planets are intriguing, compared to the number of stars and planets with stable orbits, so crashes are even more unlikely. When worlds combine, it can disrupt the orbits of the star systems within them. Though planets probably won't smash into one another directly during these big events, regions of stability for gravity can change how stars and planets move. Sometimes planets get flung out into space, becoming rogue worlds. Other times, they could collide with one another or their host stars. These disruptions could actually create new celestial bodies or make new stars. The late heavy bombardment theory suggests that around 3.9 billion years ago, there was a period of increased crashes involving comets and asteroids. This flood of impacts is believed to have occurred because the outer planets, like Jupiter and Saturn, were moving around a lot, which messed up the paths of lots of smaller objects in space. As a result, these smaller objects got thrown onto unpredictable paths, many ending up in the inner part of our solar system. This led to a big increase in crashes on planets like Earth. While these impacts didn't involve planets colliding with one another directly, they demonstrated the way that gravity can make big changes to how things move in space. This bombardment shaped the surfaces and stories of planets in our solar system. It could have even brought water and organic stuff to Earth, helping shape our planet as stars change over time.